I mean, they're tiny beads, right? I mean, tiny, tiny beads, but they're in there for abrasion. And they're durable, so they're effective at it, but they're synthetic. It's a huge problem, and it's an enormous problem globally. I saw an interesting presentation by a guy whose name I can't remember this winter, but he had gone out and collected from the plastic trash islands that are out in the middle of the Pacific Ocean, and then collected from the water, microbeads out there in the middle of the Pacific Ocean. And it's not so much the fish, it's organisms, it's smaller, so small fish and small organisms, and then it gets passed along in the food chain. So it's the organisms that go after what we call the plankton, which are the tiny little single-celled organisms, because they're about the same size as that. And they're invisible, right? Or they look just kind of like the plankton do. And it's not, I mean, it's devastating to those organisms because they can't digest it. And then there's all sorts of sort of chemical associations with it. So my colleagues here, not necessarily at PLU, we're all different areas of geology, and I haven't actually talked to a biologist about whether they've been talking about it. But I certainly see it in sort of professional discussions on a larger scale, the oceanographic world, and the marine biologists are. So it's certainly something that scientists are very aware of. It's a huge challenge because even if we say no products can have microbeads today, it's out there in the environment and in the oceans. So one question is, can you clean it up? And that challenge seems immense. You go out after the microbeads, you get all the other plankton too, to clean that up. Do I think we should ban it as a product use? I'd love to see that happen. Are there some things that could be substituted? Yes, I don't think it should be anything synthetic. There are materials that could perform some of the same things that are natural materials. Do we need it in the products at all is another question. Well, the breakdown is typically what people are referring to with biodegradable. Harmful or not can still exist even after it breaks down because it breaks down into its chemical components. These plastics were developed because they were durable. And so plastic has a really difficult time being biodegradable. In the sort of simplest of senses, food waste you can put in a compost pile. That's biodegradation, right? It's breaking down naturally. Paper, cardboard, things like that, that will break down so long as it's not coated with something else. But once you start getting into these synthetic compounds, an awful lot of the time they were developed to be durable and resistant. I would encourage people to switch products, and there are, as I'm sure you guys have found in your research, there's all kinds of resources out there about what products have it and what don't, and there's lists about that for just about everything. What's the green choice? And there's lots of choices, right? And the whole idea of microbeads being in there for abrasion, you can achieve abrasion in different ways. You can have a washcloth or a scrubby that does the abrasion instead of having it built into the product. Things can disappear from use, as you say, sort of peer pressure, societal pressure can have that effect. I think one of the things that's going to be interesting to look at is whether the big oceanic ecosystems start to be seriously impaired by this. So that, you lose the small critters that are eating the plankton and that are eaten by the bigger critters. So do you have fish populations, big, harvestable fish populations disappearing because there's no small critters to feed the bigger ones. And it takes a long time. It takes a couple of generations for people to really get scared by that kind of a change. I can only hope. as I say, I think it's going to take something drastic before people are willing to say this is more important than some other environmental problem out there.